Hello, my dear friends. Today we are going to start our next lecture series about the mole concept. Because the mole concept it is a very important and most important topic which everyone from its 9th, 10th, 11th, 12th and onwards, it's that very topic which everyone encounter with in terms of if I'm talking about the physical chemistry, when we are dealing with the reactions and we have to calculate the mass percentage, and at that time we also use the mole concept. In today's lecture we will only focus on some basic terms or some basic definitions which we are using in understanding the mole concept. Before going into the mole concept, I will start from very basics, from very basics, which is from the atomic theories. Everyone has read about the atomic theory. Number of atomic theories has been given, but the one which is the most famous, which everyone knows, our child knows, which is the Dalton's atomic theory. Dalton's atomic theory. Dalton gives some postulates about the atom. The postulate number 1 of Dalton's atomic theory was that the matter is made up of indivisible particles called as atoms. Atom. The first postulate of Dalton was that the matter is made up of the such smallest particles which on hammering we can't break it further. By using of the hammer, by using the machines, we can't break the particles further. That particles then given the name as the atoms. And the second postulate of Dalton's atomic theory was that atom can neither be created or not destroyed. Destroyed. What does it mean? It simply means that the atom is that particle which we can't generate or which we can't destroy. The atoms can't be destroyed. And the third postulate of the Dalton's atomic theory was that the atoms of an element having same nature the same nature. Same nature means the size of the atom is same, the color of atom is same, and the dimensions or the color, the volume, the size, everything is same. If I'm talking about the atoms of an element, we know that the atom elements are those substances which are made up of only single type of atoms, and the atoms of that element are having the same nature, which means the size of that atom is same, color of that atom is same, and the environment of that atom is same. and all the atoms which are present in that element having the same environment. And the fourth postulate of Dalton's atomic theory was that the atoms of different elements having the different in nature, or we can say the atoms of the different element having the different in nature, which means the different elements having the different atoms, which means different elements having different atoms. What does this fourth postulate means? It means if I am having one element of hydrogen and second element of carbon dioxide, carbon, the atoms of carbon are having the different nature, the atoms of hydrogen are having the different nature. So the atoms of hydrogen will not be the same as that of the carbon. So the elements having different atoms. The elements having different atoms. This was all about some basic, or we can say the Dalton's atomic theory, the postulates of Dalton's atomic theory. Moving forward, I will talk about something about the matter. Everyone knows what is the matter. Matter. Anything that have shape, size and volume is said to be as the matter, or which we can felt by any of our five senses. That thing is called as the matter. If I am dividing this matter into two components or two classifications, matters can be classified into two different classifications. One is the physical classification, and second is the chemical classification. In the physical classification, we divide the matter into three different subclasses on the basis of the physical state. One is the solid, liquid and gas. And in the chemical classification, we generally divide it into two subclasses. One is the pure substance, and second is the mixture. Pure substance and mixture. Physical classification, solid, liquid and gas, and in chemical classification we have the two classes. One is the pure substance and second is the mixture. The pure substance is further divided into two subclasses. One is called as element and second is called as compound. Element and compound. The mixture is further classified as homogeneous mixture and heterogeneous mixture. Talking about the solids, in solids the intermolecular force is very much strong. That is why the particles are so close to each other, and that substance is called as solids. And in case of the liquids, this intermolecular force is a little bit weak than the solids, and in case of the gases, the intermolecular forces, the particles are far away from each other. In case of the gases, that is why the gas particles are roaming all around us. And in case of the chemical classification, we have the pure substance, we have the mixtures. Pure substance are those substances. Pure substance does not mean which have any, which don't have any impurity. Pure substance, if I'm going to buy some milk from a shop, the shopkeeper uses to say me that it is 100% pure, but it does not, for a chemist, it does not mean that is the milk, the packet of the milk, it is 100% pure. It's not pure. For a chemist, pure substance or those substances which are made up of the same, same type of the particles. But in case of the milk, in milk we have the different types of the particles, like we have the proteins, different caseins is there, water is there, some coloring reagent is also present in the milk. So we can't, as a chemist, we can't consider milk as a pure substances. The pure substances, it has been divided into the element and the compound. The elements are the substances which are made up of only single type of atom, that is called as the element. And in case of the compounds which are made up of the same type of the molecule, like I'm having the water. The water in the pure state, it is the H2O, and in every part of the water I am getting this formula as H2O. Your question will be that there are the two atoms, how you can classify their compound in pure substances? Because the water is a molecule, it is a molecule, and if I'm going anywhere and I'm getting the water from Australia, from India, from Pakistan, from everywhere, the water will be having the only one formula, that is H2O. That is why I consider this water as the pure substance. And in case of the mixtures, I'm having the two subclasses, what is the homogeneous mixture and the heterogeneous mixture. In homogeneous mixture are those substances or those mixtures in which we are having only a single phase. We are mixing something, but we are getting only one phase of that substance. It is like that. If I'm taking the glass of water and I'm dissolving the sugar in it, and I'm dissolving, and at the end of dissolution of the sugar, I'm getting only that. I'm not getting any molecule or any particle of the sugar. I'm not seeing that any particle of sugar is roaming in the glass of the water. It has the only one phase, that is the liquid phase, which means that the mixture is a homogeneous mixture. And in case of the heterogeneous mixtures are those mixtures in which we are getting the two distinct phases or two different phases. Which means I'm dissolving oil in a water. I'm getting, though these two are liquids, water is also liquid, and water is liquid, and oil is also liquid. But the phase difference is between water and the oil, which means that it is a heterogeneous mixture. If I am taking the general example of heterogeneous mixture, I am taking the beaker of water and I am putting some sand in it, and this will be the heterogeneous mixture. So this was all about the matter class. In today's class, I will be only focus on some definitions or some concepts which we are using in understanding the mole concept. The first definition will be, which we are going to understand today, will be the atomic mass. Relative atomic mass. Relative atomic mass. What does it means, the relative atomic mass? If I'm having, when I'm relating something with that thing which has already been measured, that is called that I'm relating the thing with that. Like if this is my scale, consider this black marker as my scale, which has already been marked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters. If I'm going to measure this cap, I'm relating the cap with this marker because the marker has a standard unit and it has already been measured. And in case of the atoms, we have already measured an isotope of atom, that is carbon 12 isotope. And when I'm relating other atoms or other elements with that atom or with that element, that is called as relative atomic mass. That is called as relative atomic mass. It will be equal to mass of one atom of element upon 1/12 mass of carbon 12 isotope. Isotopes means which have the same atomic number but different same atomic number but having the different mass number. That is called the isotopes. What does this means? We are going to simplify this equation, which means that the mass of one element upon the 1/12 mass of the carbon. We know that the mass of atom is always equal to the number of nucleons present in that atom. The nucleons are those substances which are present in the nucleus. If I am getting that the number of nucleons in the nucleus, and we know that the mass of the nucleon are approximately same, and the mass of atom are only because of the two important nucleons, or we can say them we are having only three fundamental particles, that is electrons, protons and neutrons. And the mass of atom is because of only two nucleons, which are the neutrons and the protons, and the mass of these neutrons and the protons is approximately same, and it is 1.66 into 10 raised power minus 27 kg. And if I am writing this mass in terms of the grams, it will be 1.66 into 10 raised power minus 24 kg. So this is the mass of proton and neutron, or mass of single proton or single neutron. It will be the 1.66 into 10 raised power minus 27, and in terms of grams, it is 1.66 into 10 raised power minus 24. So the mass of one atom of an element, I can write this as the number of nucleons present in that atom into mass of one nucleon. It means that the mass of one atom, it will be equal to how many nucleons are present, and what is the mass of one nucleon, as we already know that the particles which are responsible for the mass of an atom are the neutrons and the protons, and the mass of these two are approximately equal. So now, I will write that how many number of protons and neutrons are present, which we consider as the number of nucleons, and what is the mass of one nucleon. It's okay delete. I think it is okay. I will write this 1 by 12 as it is into mass of carbon 12 isotopes. We know that the number of nucleons present in carbon is 12 into 12. So number of nucleons, it means that the number of nucleons present in carbon or 12 into what will be the mass of one nucleon. It will be the mass of one nucleon. So here this 12 and this 12 will go. This mass of nucleon and this mass of nucleon will go. I can write it in simple terms that RAM, which means the relative atomic mass. So I can write here that the relative atomic mass will be equal to number of nucleons. So here the relative atomic mass will be equal to number of nucleons present in that atom, because this all will be cancelled out and I am getting only the number of the nucleons. So the relative atomic mass will be equal to the number of nucleons present in that atom. If I'm having the carbon, so the relative atomic mass of the carbon will be the 12. It will be having the no unit. If I'm having the oxygen, the relative atomic mass of oxygen will be the 16. If I'm having the nitrogen, the relative atomic mass of the nitrogen will be the 14. So this was all about the relative atomic mass. I hope you are getting this, and we at the last we get the relative atomic mass will be equal to the total number of nucleons present in that atom. And the second term we are going to discuss about the atomic mass. Before discussing about the atomic mass, we will discuss something about the atomic mass unit. AMU, atomic mass unit, Dalton. Sometimes we use the term as Dalton 2, and in the modern time we use it as U, which means the unified mass. Unified mass, and the AMU, which means the atomic mass unit. Atomic mass unit, which simply means that the atomic mass unit. It has been 1 AMU was calculated that it is 1 AMU, sorry, I was written as the AUM. It is AMU. It's equal to 1 by 12 mass of carbon 12 isotope. I can write it as C12 isotope. This was the 1 AMU was equal to the 1 by 12 mass of carbon 12 isotopes. So when I write it as 1 AMU, it will be equal to 1 by 12, as we are right in the previous case. It will be 12 into number of nucleons, or mass of nucleon, mass of one nucleon. This 12 and this 12 will go, and 1 AMU will be equal to mass of one nucleon. It is approximately 1.66 into 10 raised power minus 27 in case if I'm calculating it in the kgs, or if I'm calculating it in the grams, it will be 1.66 into 10 raised power minus 24. minus 24, though, so that the 1 AMU will be equal to 1.66 into 10 raised to power minus 27 in case of kg, and in case of the grams it will be the 1.66 into 10 raised to power minus 24. So when I'm getting the value of this, so in place of this I can write it as 1 AMU. So the term which we are going to discuss is the atomic mass. Atomic mass is always calculated in terms of AMU, or sometimes in terms of grams too. If atomic mass it means the mass of one atom of an element, mass of one atom of an element. We know that the mass of one atom of element, it is equal to the RAM. In the previous case we have already calculated it as it will be the RAM, relative atomic mass. It will be equal to relative atomic mass into AMU. If I am giving the units to it, it will be AMU. Relative atomic mass into AMU. So if I'm calculating the atomic mass of first we will consider the carbon. It will be in the relative atomic mass. I will write here as relative atomic mass, and I will use the atomic mass. Relative atomic mass and atomic mass, and the first element is carbon. So the relative atomic mass of carbon is 12, and in the atomic mass of 12 will be 12 AMU, or U, unified mass. Or if I'm considering taking the nitrogen, it will be the 14. Nitrogen will be the 14, and the atomic mass of nitrogen will be the 14 AMU, or unified mass. Or if I'm taking oxygen, it will be the 16, and it will be the 16 AMU, or U. If like this, the only thing has changed from the relative atomic mass is the unit. In atomic mass we giving the unit as AMU, and in the relative atomic mass it was the unitless. It was in case of oxygen we are having the relative atomic mass as 16 and atomic mass as 16 AMU. If I am going to convert this AMU in terms of the grams, or if I am going to calculate this atomic mass in grams, it will be simply equal to 1.6 into the value of 1 AMU, which we have calculated already. It is equal to 1.66 into 10 raised to power minus 24 grams. When we solve this, and we get the value, we get the mass of oxygen in terms of grams simply. Or if I am going to calculate the mass of carbon in grams, it will be the carbon will be equal to 12 into, in place of AMU I will multiply it with 1.66 into 10 raised to power minus 24 grams. And when we solve this, and we get the mass of carbon in terms of grams. This was about the atomic mass, and going to touch something about the mole. It is the fourth, I think it's the third definition. Mole is simply as a number, like we are having the meter scale, 1 meter, 2 meter. There we are having some numbers like or if we are going to call dozen, which means the number is 12. Always half dozen means the number is 6, and 100, which means that the number is 100, 100. 1000 means that we are having the number like this. 1 mole is the same. It is the number of particles when we are having the number of particles equal to Na. Na means that the Avogadro's number. The Avogadro's number, the Na is equal to 6.022 into 10 raised power 23 particles. Which means whenever I'm having this much of particles, when I'm having the Na particles, which means 6.022 into 10 raised power 23, I call it as the 1 mole. If I'm having the twice of this number, I will call it as 2 mole. If I'm having the thrice of this number, I will call it as the 3 mole, and so on. It is the number of particles when the number of particles is equal to 6.022 into 10 to the power 23 particles, that is called the mole. We are not going into the mole concept in deep. I'm giving some highlights, some points which we are going to use in the mole concept. This was about the mole. When we are having the n number of particles, which means the Na number of particles will be equal to 6.022 into 10 to the power 23 particles. That when I'm having that much of particles, that much of ions, that much of molecules, that much of atoms, I will call it as the mole. Only I will not consider it only for my atoms. If I'm having this much of particle, this much of eggs, this much of apples, I will call them as it is the 1 mole. So, and the fourth definition, which we are going to use is the gram atomic mass. Gram atomic mass. When we are calculating the mass of atom in grams, mass of 1 mole of atom in grams are called as the gram atomic mass. Gram atomic mass means that the mass of 1 mole of atom in grams, that is the gram atomic mass. If I am having the oxygen, I am going to calculate the mass of 1 mole. 1 mole means that any number of particles means that 6.022 into 10 to the power 23 particles. Fine. So I know that the number of nucleons present in or will write it as RAM, relative atomic mass, into number of moles. It is the mass of number of nucleons in one atom, into the number of molecules, or 1 mole. 1 mole will be equal to 6.022 into 10 raised power 23 into the, if I am going to calculate it in grams, and I will simply multiply it with the number 1.66 into 10 raised power 23 grams minus 23 grams. Here comes some magic. When we multiply 6.022 into 10 raised power 23 into 1.66 into 10 raised power minus 23, here comes a magic, and it will approximately equal to 1. So the relative atomic mass of oxygen is 16, and the oxygen, it will be 16 when I will multiply 6.022 into 10 raised power 24 is here. The 6.022 into 10 raised power 24 into 1.66 into 10 raised power minus 23 grams, and I get the answer it as 1. So I will multiply it at 1 by 1 gram, because this is in terms of grams. It will be 1 gram, and to calculate the mass of gram atomic mass of oxygen, it will be the 16 grams. Simply, or if I am having some other elements, some other atoms. I will try to calculate the gram atomic mass for those elements too. If I am having the nitrogen, the relative atomic mass of nitrogen is 14, and I will the mass of one nucleon is 1.66 into 10 raised power 23 grams, minus 23 grams into the I'm going to calculate the mass of 1 mole, so I will multiply it with by the number 6.022 into 10 raised power 24. So when we will multiply this with, we get the answer equal to 1, and the gram atomic mass of nitrogen will be the 14 grams. And simply for the carbon, it will be the 12 into, so this is the magic 1.66. when I will here multiply it with by 1 gram only, so the carbon will be the 12 grams. And simply for other elements, we have if we already have calculated that the atomic mass AMU, in terms of AMU, we have only changed the AMU with the grams, but the much difference and the great difference is that we are calculating it for the 6.022 into 10 to the power 24 for 24 atoms, or for 24 atoms. When we calculated it is 12 grams of atom, and when we calculated that the mass of 1 atom in grams, it was equal to 12 into 1.66 into 10 raised power minus 24 grams, which was it is 24 and it's 23. And 12 into 10 raised power 20 minus 24 grams. This is much more smaller than this. It is 12 grams. It is 12 into 1.6 into 10 raised power minus 24 grams. It means it is lower. It is the mass of 1 atom. It is the mass of 1 mole of atom, which means that the 6.022 into 10 raised power 23 atoms. So the mass of the 1 mole of atom or gram atomic mass will be simply as this. Moving forward, we will talk about something about the molecule. Molecule is that substance which have its free existence, and we will like we calculate the gram molecule has its free existence. So if I'm having the molecule of water, the molecule is made up of 2 or more atoms. When we combine 2 or more atoms together, we get molecules. If I'm going to calculate the molecular mass, it will be equal to the, we know that it's made up of the atoms, hydrogen atom and oxygen atom. If I'm going to calculate the molecular mass, we have to calculate the individual atomic mass of hydrogen, individual atomic mass of oxygen. Then we have added, if it is the A, if the individual atomic mass of the hydrogen in the water molecule is A, and the individual atomic mass of oxygen in the water is B, and we will when we will calculate A and B, then we have to add A plus B, and we get the C, and this C will be the molecular mass. It will be simply the molecular mass. So if I know that it is made up of the hydrogen, the atomic mass of hydrogen is 1. I'm having the 2 hydrogens. I will multiply it with the 2 plus I'm having only the 1 oxygen. It will be 1 into the atomic mass of oxygen. It will be the 16. It will be the 16. 2 into 1, it will be the 2. 16 into 1, it will be the 16. When we add 2 plus 16, it will be the 18, and the 18 unified or AMU, if I'm calculating it in AMUs or in unified mass, it will be the 18. And simply if I'm going to it will be the 18 AMU or 18U. Like I'm having S2, it will be the 2 into 1, it will be the 2 unified mass, and simply you can calculate it for the large number of the molecules. And the concept which I am going to understand you is that the gram molecular mass, GMM, gram molecular mass. Gram molecular mass of 1 mole of molecule is called as GMM, as gram molecular mass. So it will be equal to the relative atomic mass, or we will say as it is relative molecular mass, or molecular mass into 6.022 into 10 raised to power 23, or we can write it as molecular mass into Na, which means the mass of any number of particles. Mass of 6.022 into 10 raised to power 23 particles is called as gram molecular mass. If I am going to calculate the gram molecular mass for hydrogen, it will be equal to, we already know the molecular mass of hydrogen, it is 16U, and if I will multiply it with the Na number, which means that the 6.022 into 10 raised to power 23, I am getting into if I am going to calculate in grams, I will multiply it with the mass of the nucleon, which is 1.66 into 10 raised to power 24 grams minus 24 grams. When we multiply this, there is a magic, it will be equal to 1, and it will be a 1 gram, and it will be the 18, which is 18, it will be the 18 grams. So the gram molecular mass of water is 18 grams, and same you can calculate it for the mole number of the. So at last we get this was some basic concepts which we are going to use in the mole concept. There are some cases which we are going to discuss. If I am having number of moles, mole it will be equal to weight upon the molecular mass in case of the molecules, or in case of the molecules, and in case of the atoms it will be the atomic mass, atomic mass. If I'm so the number of moles, it is represented by small n, which means the number of moles, it will be equal to weight, I will represent it with W, and the molecular mass or atomic mass, I will represent it with by M. So this is going to be the formula that we are going to use in some questions. I'm giving you some questions, and we use this very formula to solve these. So question number one is the find the moles of mole of 40 grams or 49. I will check it first. 49. Find the mole of 49. Find the mole of 49 grams of H2SO4. We know that number of moles equal to weight upon the molecular mass. Weight of H2SO4 is given, it is 49. So I will write it as 49, and the molecular mass of the H2SO4 is 98. When I will calculate it, it is 1 by 2, it will be equal to 0.5. So the number of moles will be the 0.5 moles, and is equal to 0.5 moles. We are find the moles of 49 grams of H2SO4. We know that the molecular mass of H2SO4 is 98, and the mass given is 49. When we calculate this, it is equal to 1 by 2, which means that 0.5. It means that the N is equal to 0.5 moles. 0.5 moles. Question number 2 for you people is that find the weight of the 3 moles of urea. Find the weight of 3 moles of urea. First, try it by yourself, pause the video and try to get the answer. And mole of urea equal to NH2CO NH2. What will be the molecular mass? It will be the 14 plus 2, 12, 16, 14, 14, and add this, it will 14, 15 and 16, 16 and 16, then add 16, then add 12. It's approximately equal to 60. It will be the gram molecular mass or molecular mass. We know that here in the question we are giving the number of moles, that is 3. We know that we know the formula is N equal to W, which means that the weight which we are going to calculate upon the molecular mass which we have already calculated, which is equal to 60 grams. So number of moles, it is 3 equal to weight upon the molecular mass is 60. So the weight will be equal to this will multiply by with this, it will be equal to 60 into 3. Weight will be equal to 60 is 18, it will be 180 grams. 180 grams. So for 3 moles of urea we need 180 grams of urea, which will be equal to 3 moles of urea.